students, welcome back to geometry. Today we're going to be talking about something called the tangent ratio. Now, we've done something with some special right triangles, so I'm going to go ahead and just start off by drawing one of our special right triangles. So this would be a 30, 60, 90 triangle. And if you remember, we have 1, 2, and square root of 3. That's the basic sides of our 30, 60, 90 triangle. So we would say something like, if I had a smaller triangle like this, and this side was actually only 1/2, well then I would know that the hypotenuse of this 30, 60, 90 triangle would be twice as big as the short side, so that would be 1. And the longer side would be the short side times the square root of 3, so that would be the square root of 3 divided by 2. We've done some homework on this, and we've been able to do lots of calculations with this. Now, what we're doing here is we are memorizing the ratios between the sides. So, if I have the short side to the long side, and the hypotenuse, I could say that I have a short to long ratio, and that would equal 1 over the square root of 3, and that would always be the same no matter what 30, 60, 90 triangle I'm talking about. So if I do a quick calculation on that, I would get 1 divided by square root of 3, and the ratio of the short side to the long side is always going to be 0.577. Now, what if I'm not doing a 30, 60, 90 triangle? What if I am doing a 31, 59, 90 triangle? How would I figure that out? So, if you look at your calculator, you should see some buttons that look like this: sine, cosine, and tangent. So those stand for sine, cosine, and tangent. Sine, cosine, and tangent are the 3 basic trigonometric ratios, and those 3 ratios are used for figuring out what the relationship is between 2 sides of a right triangle for any given angle, not just 30, 60, 90, or 45, 45, 90. So in our case, I just want to show you that if I wanted to find the tangent of the 30 degree angle, that would be the short side divided by the long side. So if I type this into the calculator, watch what happens. The tangent of 30 degrees is equal to, and I get the exact same number. So, how does that work? Let's talk about that. So, first we're going to start off with a right triangle. Here's 90 degrees. Now, we're going to pick an angle, so that would be like this. And that circle with the little line through it is the Greek letter theta. Theta is just a variable, and the reason that we use theta is just to signify that we are talking about an angle. So we could use x, we could use y, we could actually use the letter name of the angle, but anytime we use theta, we are talking about an angle. Now, if I start at theta and I go straight across to this side right here is called the opposite side. If I start at the 90 degree angle and go straight across, we always land on the hypotenuse. And then the other side that is not the opposite or the hypotenuse, the one that is touching theta, that's not the hypotenuse, this is called the adjacent side. Now the tangent ratio is simply the tangent of theta is equal to the opposite side divided by the adjacent side. So in this exercise right here, we're trying to solve for x. Now, normally we would solve with the Pythagorean theorem, or we would use a special right triangle. However, I know that this is not a 30, 60, 90 triangle because it has a 90 and a 32. So this is actually a 32, 58, 90 triangle. So what I'm going to do here is just start off by identifying some pieces. So right here I have my angle. So I would say that theta is equal to 32. If I go directly across from theta, I get the opposite. So I know the opposite is 11. And then I know that the adjacent, right here across from the 90, this is the hypotenuse. So the adjacent is x, and the hypotenuse is, I don't know. We're not going to use it anyway, so I'm not going to worry about it. So all I need to do in order to set up this ratio is say the tangent of theta is equal to the opposite divided by the adjacent. So substituting my values in, the tangent of 32 is equal to 11 divided by x. Now, just a heads up, this is not an ideal setup right here, so this is going to be a little bit more difficult, and there is an easier way. I'm going to show you the easy way in just a second, but let me go through it the more difficult way first. So the thing that makes it more difficult is the fact that the variable is in the denominator, so I need to take an extra step to get it out, but we'll deal with that in a second. So right here, tangent of 32, this is a number that your calculator knows. Your calculator knows if I have a 32-degree angle, what are the ratios between the opposite and the adjacent. So I'm just going to type in tangent 32. And there's my answer right there. So I'm just going to take the first 4 decimals right now. So tangent of 32 is 0.624, and then I'll round up to 9, equals 11 over x. Now, to solve for x, first I need to get it out of the denominator. So I'm just going to multiply both sides by x, and that will give me 0.6249x is equal to 11. And now one more step. Let me divide by 0.6249. And then I will get, I can't do that in my head, I'm going to use my calculator. 17.6028. X equals 17.6028. And for our homework, we'll round to the nearest tenth, so we'll say x equals 17.6. That's the answer. Now, I did say that there was an easier way to do this. So it's always easier if I can have the variable in the numerator. So I'm going to go up here, and I'm going to switch this around a little bit. Here's the thing that we can do. Let me erase some stuff here. Okay, so if this is a 32-degree angle, I know that the other angle is 58. So I can always choose to use the other angle, and that'll work as well. So instead of using 32, I can say theta is 58. Now, starting at theta and going across, that would make the opposite would be x, and the adjacent would be 11. So, doing my calculations a little bit differently, I would get tangent of theta equals the opposite over the adjacent, tangent of 58 is equal to x over 11. And you'll see how this one, the calculation's a little bit nicer, because if I go in here and just type this in, tangent of 58, I get 1.6003345, and like I did before, I'm just going to use the first 4 digits. So the tangent of 58 is 1.6003 is equal to x over 11. And now in this one, the variable's in the numerator, so all I need to do to solve this is multiply both sides by 11, and I get x is equal to 11 times 1.6003 is equal to 17.6033, but like I said, we'll round to the nearest tenth on our homework, so it'd just be 17.6. Let's do one more example. Okay, so in this case, I've got 61 right here. And if I go directly across from 61, I know that this is going to be the opposite, this is going to be the hypotenuse, and then the x is going to be the adjacent. So I would get the tangent of 61 degrees equals opposite over adjacent. Now already I can see this is one where the variable's in the denominator, which means it's probably going to make my life a little bit harder. So using the triangle sum theorem, if I have this angle is 61, the other angle would have to be 29, because all 3 angles of a triangle have to add up to 180. Now, across from the 90-degree angle is still the hypotenuse, but now across from theta is the opposite, and the other side that's not the hypotenuse, not the opposite, this is the adjacent. So now I can say theta for this one is 29, the opposite is x, and the adjacent is 22. So I can say tangent of theta is equal to the opposite divided by the adjacent. Opposite divided by the adjacent. So the tangent of 29 is equal to x over 22. Let's go ahead and calculate the tangent of 29. 0.5543. So 0.5543 is equal to x over 22. And then we'll just multiply both sides by 22. And these will cancel out. 22 times 0.5543 is equal to 12.19. So if we round to the nearest tenth, that would be 12.2 is equal to x, and we're done.